Welcome back to Database Fundamentals. This is the beginning of Module 3 of the Database Fundamentals course. Module 3 is going to be a fun one. We're actually going to talk here in this module about creating databases and database objects. So
we get to create something finally.
We finally actually get to do something real instead of all this theoretical stuff that we've been doing. But let's just review. In Module 1, we talked about sort of core concepts of databases, some terminology, things that we've covered. Then in Module 2, we talked about, what did we talk about? We talked about referential integrity and normalization and sort of a little bit of modeling, but not quite modeling. We didn't get into some of the details of modeling, but we talked about referential integrity, normalization, a little bit about constraints. And now here, finally in Module 3, we're actually going to create our first database. We've only looked at diagrams so far, except for your quick demo of SQL Server Management Studio. We're going to create databases. We're going to create database objects. You're going to tell us what kind of objects we're going to create, things like that. And then in 4 and 5, we're going to head on, coming up, we're going to talk about how we actually use those objects with this T-SQL language in Module 4 and then administration in Module 5. So
some real work. Some real stuff now.
Let's create. I can't wait to see how this is going to go.
So yeah, creating databases and database objects. First thing we're going to talk about data types, because before we can create objects, specifically a table, we need to understand what types of data we're going to store in there. And that's really huge about, it's huge to understand. So we've kind of talked about creating different columns. We've talked about creating the artist ID and the album ID. Well, we need to identify what type of data is going to be stored in each of these columns. So it's not as easy as it is in Excel where you just throw a column out there and just say, yep, just throw whatever you want in that data in that column. We actually have to think about, this helps with the data integrity, we have to think about the type of data we're going to store there. We're going to store numbers in there. We're going to store money. Is it going to be a date field? Is it going to be a character field? And we have all sorts of options. So we're going to introduce data types first. You have to have an idea as to the type of data that you're going to store. That's something you need to do and think about in that data modeling phase that Pete had brought up earlier. So we'll look at data types. So we'll look at database objects. We're just going to mention just a few of them, the most commonly used objects. And then we'll look at DDL, data definition statements. So statements are used for defining new objects. So we'll introduce the statements that are available associated with DDL statements, and then we'll use a couple of those statements just to show you how they all work together with us. So data types is going to be our first category that we're going to talk about. And in here we're going to begin with an understanding what that is. So we've talked about rows and we've talked about columns. Well, the columns are what we use to identify that we assign a data type to, which identifies the type of data that's going to be allowed or stored in that particular column. You have similar data types. There might be a couple different data types that are similar. The idea is use the data type that has a larger range of values just to make sure that you have a better chance of increased precision, and you make sure that you don't have an overflow error by not having a data type large enough to be able to store the content. Some exact numeric data types are int and tiny int, and these are probably the most commonly used data types because they're storing numeric information. And then we have approximate numeric types. These include precision, so it's indicated by a letter P, and that gives us the total number of digits, decimal digits, that can be stored both to the left and to the right of the decimal point. So all of this has to be considered when you're trying to decide what columns am I going to create for my new table, for instance, and what type of data am I storing in there. When we talked about the album ID, is normally going to be, most likely going to be a numeric type value. Description or title or artist, that might be more of a character field. So these are things that we need to think about. The other thing we need to think about is how are we going to use these forms, these columns or data types. For instance, if I go out and I create a data type of a character field and I put a number in there, I'm not going to be able to use that in a calculation. I can't multiply in a character field. It has to be a numeric field for that operation to take place. So there's some things that we need to be aware of when we're working with our data types. We have what are called Unicode data types. You'll see that often. These provide storage for international characters. So non-Unicode data types are pretty much specific to the USA and the New England, or not New England, English data types or characters. But if you want to bring in other languages, native languages, we have to use the Unicode data types. Unicode data types take more storage in the database itself, but you have to be careful about that. But those two things are a couple concerns that we have to think about when we're looking at data types. Now, there are several categories that are provided with us with SQL Server 2012. And I mentioned already we have exact numerics. We have big int, and we have bit, we have decimal, int, money, approximate, float and reals, date and time, I mentioned that one, character fields, Unicode character strings. Then you get the letter N before, that means it's Unicode. That provides support for the international languages. Binary strings, and we have some unique data types, other data types like a timestamp or a unique identifier. Some of these are actually taken care of or managed by SQL Server. So it actually, timestamp, for instance, it stamps, takes a system time, it stamps that or applies that to the record as you're applying that. And we have a couple other ones, large value data types and large object data types, which we will see for storing images or specifying the maximum amount that we want to allow in a particular field. So data types we have to understand how we're going to use them, and understand they're going to enforce data integrity for us by, for instance, if I have an int or a tiny int, I'm not going to be able to put the letter A in there because it's not the character field. So it enforces data integrity with the use of, by enforcing the information that's being supplied. It also controls what we can do with that content or those values once they've been added. So we have to make sure when we're going through this that we think through that as we're creating our data types here. So here's a couple common ones. We've got money. So if you're going to store currency, you can control these. Most of these have options where you can decide how many decimal points that you want to the right or the left of them. We have int, used to store whole numbers. We have a float, sorry.
Is int short for something?
Short int, yes. Int is short for integer. Thank you very, very kindly.
Ah. Yes.
I see, I just assumed
You blew right
everybody,
past that
I
one.
blew right past. I
That's
did it
right.
a couple times. So the tiny int is tiny integer, or the int here that we see here is integer. Big int is big integer. So some of those short names, I'll try to be more aware of that. Thank you for catching me on that.
But I also want to back up before you finish this slide. You've gone to a list of the sort of kinds of data types, numeric and non-numeric, and then you've gone into some specific data types that are actual keywords in SQL Server. So two things I wanted to say. Number one, it's specific to the database system that you're using. So right, you're talking about SQL Server, which is important because that's what our demo is going to be. But there's a different, shorter list of data type choices in Access and in other database systems,
That's
right?
correct,
And they're very similar, but that's one of the ways that the choice of what database you use, what database engine you're going to use,
right,
that's one of the deciding factors. Is if you need unique identifier or some of the really advanced data types, you might need to use SQL Server because it may not be available in Access or a smaller database engine.
Yeah, both, like you said, most of the relational database products associate with the ISO, the standard for databases. So if you learn one database, you don't have to jump over and learn a brand new data types. But Microsoft SQL Server, as other products, have some unique variations of what is available or supported, we'll say, via ISO. So,
Great.
ISO, what does that stand for again? International Standards of Organizations.
International Standards.
Yeah, one of those
trivia
things.
question.
Yeah,
that's right.
It's a trivia question. There we go. So that's all right. So we have int, short for integer. We have float. That's often used if you need more precision. We've got more in the scientific community, and then often we're looking for dates or times and stamps. So we have a date time field as well. So those are a few of the variation of those types of data. Getting the more of a couple other ones are char, short for character. And anything can go in a character field, so we can put numbers and alphabet in there. So it's a alphanumeric characters can be stored there. Variable character, so a char, which is short for character, has a fixed length. So if I do a char 20, it's going to allocate 20 spots for 20 bytes, I believe. Bytes or bits? I can't remember that.
I don't remember.
20 somethings. Chars. So it's going to allocate that number. Now, if I only use 4, there's going to be 16 unused. So it's a fixed length. A varchar, variable character length, if I put 20 in there and I store 4 bits of information, then the other 16 bits, it's only going to allocate what is needed to store the content that's in that type of field. So that's the difference between those two. Another data type is a bit. Sometimes you'll see it as a Boolean. This is often just going to return a 0, which is false, or a 1, which is true. So it may be as simple as, if I want to go out and check, does the date field equal today's date? And it returns yes, or a 1. If it does, then we can have some programmable code or programmatic code that allows us to go out and perform some other task. we can do some calculations. We can do calculations within the fields themselves, just using the data, the data types that we're creating. We can also use something like the date time offset. We're going to actually determine the difference between a couple dates or the offset of those dates. So some of that functions available to us. Here's an example of some of the different data types in the storage. For instance, as you can see, the int, short for integer, can store a number from minus 2,147,483,648 to plus, it should be plus 2,147,483,647. So it's 2 to the 31st if you look at it that way. Char, for instance, fixed length, non-Unicode data, any value from 1 to 8,000 characters. The bit we talked about already, and the date time offset we talked about already. So these are, again, things that we have to consider when we're creating our new tables, when we're trying to create our relationships between those tables. What are we going to use the data for? We could just easily create everything in char or varchar to save space, but when we do that, now we have issues if we need a date, a timestamp, or if we want to try to perform a calculation. We'll have some restrictions with that. So we have to think through this when we're going through the data modeling and designing our tables for our database. So these are some examples of the size of the information and what's stored here. Now we may have a situation where we created a data type on a field and we want to perform a calculation on it. Well, we can do what a SQL Server will do is what's called an implicit conversion. So there's implicit conversions and there's explicit conversions where I need to do the conversion myself. I need to use either cast or convert. Either of those commands allows me to take any of these data types and convert it, I won't say any, most data types, and convert it to a different data type. So if I want to be able to perform a calculation, as long as the number was in a character field and I want to convert it to an int so I can perform a calculation, we can do some data type conversions as part of our program, and we're doing some programs and using some of the different objects inside a SQL Server. But the best thing to do, is, if you can, is to create the data types with create the columns with the appropriate data types, taking into consideration the type of content or data that's going to be stored in there and any type of calculations you may be performing with that data once it's actually stored in there. And there's an example here in the slide of casting, $157.27 as a varchar. So it's going to convert that and now store that as a varchar and be able to work with that using that new data type here. But again, not everything's supported. For instance, an nchar cannot be converted to an image data type. Most everything, as you stay within the common data types, you're pretty safe. But if you're going to get into some more unique ones like image, those you have to be a little more cautious about. So we talked about we introduced the ISO. The cast and the convert can both be used for doing explicit conversion. The cast, as you can see, it's recommended you use that because it does adhere to ISO. Now, Microsoft or other products have decided to create another flavor of that called convert, and they can do so and still take advantage of that and still use it. Just gives it a little bit of a different variation. So data types, you have to understand those before you create your objects. We're now ready to create our objects. Here's our table we looked at earlier already, collection of rows and columns. We have our employee ID. Maybe that ID has a tiny int or an int data type. Last name is a varchar. First name is a varchar. Department might be a varchar with different links. Maybe we have a varchar 30 for last name, varchar 20 for the first name, department of varchar 25. We define that when we create these. And the employee ID, we decide, hey, are we going to go above a certain number? If we are, we need to decide if it's a tiny int or an int or any of the other types that will hold a numeric value for us. Now, in addition to tables, which we're going to use the most often, we have what's called a view. A view is a virtual table, and it consists of columns from either one table or multiple tables that we've pulled in, and we're going to see how one of these are created. A view is not really an object that's stored inside of the database. It's more of a query. So when I go out to use a view, it's actually going to go out and generate that information on demand. So it's not going to populate the content in the view when I create it. It's going to take the select statement, we'll say, and it's going to use that to populate and display the information that I'm looking for when I'm trying to create a view here. And here's some examples of some system views that are provided by Microsoft that are part of the SQL Server world. Stored procedures. These are just a group of transact SQL statements that have been compiled and saved so they can be used multiple times. So I may go in and run the same command multiple times. If I'm doing so, what may be easier is to create a stored procedure that I can reuse. And every time I want to perform a certain task, and in this case here, we're looking at the number of items in inventory, going back to talking about what we talked about earlier in a grocery store, for instance. I want to find out how many items are on hand. Well, I can write a store procedure, and instead of having the store procedure hold not being flexible enough to be able to be run against multiple products, I can actually have parameters passed in. So I could supply a parameter to go look for, strawberries in the produce department by supplying parameters. The next time I can run it and have it to go look for, steaks in the meat department. So I can create a store procedure that can be run multiple times over and over again. It actually gets compiled, which means it's going to run a little bit faster, be a little bit more efficient. And we can pass parameters to it so I can run it and reuse it multiple times and be able to get results back based on the parameters that I passed into it. So this is just a brief little example of how we use that and to pass parameters into a store procedure. We can create UDFs, or user-defined functions. These are routines that also can take parameters. It completes a specific operation and returns the result of that operation. And there's a few different types, and we'll see these as a couple of these at least we'll see as we're going through some of our demonstration between this module and the next module. But we have a scalar function, which is going to return a single value. So we're going to see, for instance, I want to know the average cost of something. So it can return that information to me. We have a table value. It returns a table data type. We're not going to see that one. I'm just listing a few things out here. And we have system functions, which are functions that are provided by SQL Server in this case here. And we can use those in any of our statements that we're writing, for instance. So we can use that pretty much anywhere we want to return any system type information. So a few different types of functions that we have available to us. And pretty much for this class, we're going to just focus on the scalar function and what kind of information can be returned with that here. As I introduced the stored procedures and the functions, they sounded similar, but here's an example of the differences. In order for me to execute a stored procedure, I use the execute or exec statement. I can't use join stored procedures. I can't join multiple procedures together. I can't use a stored procedure for modifying SQL Server, a configuration of it. And I can't use statements such as a get date in a stored procedure. Now, user-defined functions allows me to perform some of these tasks. I can call from within another SQL statement. So I can call a function from within another SQL statement. I can have multiple UDFs working with each other. It cannot be used for SQL Server configuration. Stored procedures can. The user-defined functions cannot. And if there's a problem with the user-defined function, it's going to stop the function and it's going to no longer continue on. Where a stored procedure, depending on what kind of error checking you've done, will continue to perform. So just a few high-level differences between stored procedures and user-defined functions as you're creating these different objects. Now, one of the things that we often do as we create objects is we have to have a naming convention. Now, a couple of the common ones are listed here. The Pascal case is where we use the first letter of the identifier and the first letter of every subsequent concatenated word is capitalized. So, for instance, you see employee table. The E in employee and the T in the table is capitalized. Personally, this is my preference. I use Pascal case, and you're going to see with the scripts and some of the content that I'm going to be showing you in this module, next module, I'm totally about Pascal case. Camel case, as you can see, the difference is, with the exception of the first word in the descriptor, the identifier, the first word is lowercase, and then every other word, every concatenated word is now is capitalized. So the first letter is capitalized. So whatever your choice is, whatever your preference is, mine, as I've shared a couple times already, is Pascal case. But whatever you're going to use, be consistent. So when you're starting to rename your objects, if you decide to use Pascal case or Camel case, use the same naming convention for everything that you're doing, so you don't get confused as to why you used it one place and something different in another place. And try to keep that as a standard within your organization, so you know you've got that consistency when you're creating these objects that we're going to be creating here. Okay. we're going to go in and create a database. There's a couple ways we can do this. We're going to show you both ways. We can do it inside of SQL Server Management Studio. We're going to jump over there. And we can also do this inside using a transact SQL statement. We'll show you how both of these work for us here. So let me jump out and go into my...
This is pretty exciting. This is our first actual database.
Yeah,
We've only seen pictures of databases so far.
Yeah, and the pictures weren't that...
Well, the quick one you showed us, but we didn't actually...
It wasn't that cool. Yeah. Well, a database can be created very easily. I mean, it's kind of like I showed you. This statement here is probably being the easiest statement you can write. Select asterisks from production.product. That's a pretty straightforward statement.
But somebody had to do the creation of the database, and then they had to create production.product.
Yeah, that's that whole schema with all the...
That's the table. So they went through their spreadsheet and figured out what tables they needed. Yeah. And once we create our database, we're going to go and we're going to talk about creating a table where we're going to use all that stuff you just taught us about the data types.
Perfect.
And then this is actually the foreshadow to the next module where we'll learn all sorts of different ways to write queries that get the data out of the database.
Yeah, exactly right. Yeah, and that's the big thing. I mean, all the upfront work that we're spending time on, like you talked about, Pete, is really, it seems like there's a lot of upfront work in getting the tables and getting the foreign keys and the primary key constraints. But once that's all done, the big bang for the buck we're going to see in the next module, you're going to see how much easier it is and more efficient it is for us to be able to retrieve that content and slice and dice it in several different ways. So let's create the easiest way to create a database is go in here to the SQL Server Management Studio, and over here where it says databases, I'm going to right click and do new database. And here's a name right here. So I'm going to call this class demo DB. Now, quite honestly, I can right here find my mouse, come back mouse. There it is. Must have been off in the real. Was it over on your screen? I don't know. Lost it on my screen. So I'm going to go ahead, and this is how simple it is from inside of here. Now, there's options that we can change here, but I want to show you how easy it is to create a database. All I did is give it a name. All right. I'm going to click OK. And if you look over on the left-hand side here, we've got a new item here called class demo database. That's how easy it is to create a database in here.
Woohoo!
Now, was it efficient? Did I do everything I should have done to make it as optimal as possible? Absolutely not. But I wanted to show you, if you want to do something today, say, hey, create my first database, open up SQL Server Management Studio if you have access to it. Remember, SQL Server Express is out there if you want to dabble with this. And then go in, right-click database, give it a name, click OK, and go out and have a baby, because you just created your first database and you're into the SQL Server world at that point. Again, a lot more we can do. To make it a little bit more complex, let's say we like to type. We want to practice our typing skills. I'm going to actually go out. I created a script file the other day. And I'm going to open up a script file. I'm going to talk a little bit more about scripts. I'm going to open this up here.
We should talk, while you're doing that, you've referenced this thing called T-SQL. Can you just explain what you mean by T-SQL?
T-SQL is like in golf when you tee up. It's not like that at all. Okay, so I do know that much. But T-SQL is Transact SQL. It's Microsoft's flavor. We talked a little bit about ISO standards just a couple of minutes ago. So whether you're using SQL Server or using your MySQL, or if you're using Access, they all have a different flavor of statements that you're going to use. They're all very similar. We talked about that. Most all of them will adhere to the ISO standard. I know it sounds redundant, but saying ISO sounds weird by itself. So most will all adhere to that, and then most of them will have variations. They might, for instance, we had the cast, but we have a variation of which was convert, so we can have variations of the different commands. But T-SQL is Transact SQL, and that's Microsoft SQL Server's flavor of issuing or writing commands, as we're going to do. So even doing that select statement, that was a T-SQL statement. Creating a database, as we're about to do, is a T-SQL. So anything that we do, pretty much anything that we do, even inside of a stored procedure or inside of a function, it's ways for us to query or manage or manipulate data inside of SQL Server. Is that clear? Does that make sense?
Yeah, that's better. Because you're about to go ahead and open that file. Yeah. Which we're going to use for the demo, which is full of these T-SQL commands.
So the cool thing is, what I've done so you guys can see, trust me, Pete was watching me type yesterday, he fell asleep. Because I'm fat fingering stuff, I don't have the proper quotes, or I forget a quote, or I got too many quotes, or it was just always making mistakes. So what I've done to avoid the pain for you folks is I've I set up these queries, and I'll show you how to execute them, and I'll explain what every one of them means as we're going through them. So I just showed you an easy way, as easy as it gets, to create a database. I go into SQL Server Management Studio, I right-click on databases, I do new, I add a name, I click OK, done. I create a new database. Now, if you like to practice your typing skills, here's another way we could have done that. All right, a little bit more complex, but let's walk through this. This is a transact SQL statement. This is going to create a database called sales, and then and we're going to give it a logical name called sales underscore dot. And whenever you create a database, it gets two files that are created on the drive, and I'm happy to store these on the SQL on the C drive. And my sales.mdf file is created, and that's going to store my content. And the size of that's going to be 10. The max I'll let that size of that file go is 50. And if it needs to stop and grow, it's going to grow in I call baby increments, 5 megabytes at a time. So what this does for me, when I create this file that's going to store my content, the size is going to be 10. If I'm at 9 and I try to add a 4 megabyte file, I'm short 9 and 4, 30, I'm short 3 megabytes. So what this does, like, well, I've got auto growth on, so it's going to grow, it's going to stop, it's going to grow by 5 megabytes. Now it'll let me to continue to add that content. The bad thing is it's going to keep doing that every time I need to add content. So different story, but we can actually change these and set these to be a bit more appropriate values.
But I think specifically, you showed us you could right-click and do create database, and you alluded to a whole page full of options that I could have set.
Yeah.
In your script is using the create T-SQL statement to create a database.
That's exactly right.
And it's specifying a variety of those options in code. So you can do it with the graphical user interface.
Perfect.
Or you can do it with code. It's just a different way to create the database.
Yeah, I just showed you the easiest way to create the database was right-click, bam, you create the database. You're exactly right. If I went in there and looked at options and I looked at files, I could change that so the size equal 10, the max size equal 50. I could specify the file name, the file location. I just wanted to show you just to give you the opportunity to create a database. That was the quickest, easiest way to do that.
And I think this is an opportunity to call out. We've got a bunch of training about SQL Server specifically, and in the database administration course that we have, you can actually learn all about the different ways to create a database for optimal growth and minimal size and those sorts of things that you're calling out in your script here.
Yeah, optimizing databases. Again, this is the DB fundamentals, so trying not to go too deep. Hope Pete's keeping me on track with that because I start digging deep, and next thing I know, I'm like.
Well, the concept is sound, right? In Access, we can create a database by doing file new because it's more of it's a desktop. It's not a database server product like SQL Server. And in MySQL, there's a way to create a new database, and they all have these kinds of parameters about how big should it be and what's the file going to be on disk and those sorts of things. But the concept is it's a simple create statement. SQL Server uses this query language called T-SQL that you can use create, or you can just right-click in SQL Server Management Studio to create the database.
Yeah, so it depends. If you get paid by the hour, you'll want to learn how to type these in. If you get paid, if it's just getting the work done.
But show us that it runs now. I don't.
You don't believe me?
I want to see it happen because you did one with the graphical user face.
Right. So this is.
I also want to see you've got a whole long page of scripts there. I can't wait to see what we're actually going to do.
I got some other cool stuff in here. This one's a small one compared to the next module. So this is the MDF, the data file. It also uses something called an LDF file, which is a transaction log. Again, all of the most relational databases uses what's called a transaction log style. So every data modification, not retrieval, but modification, is stored in a transaction log file, in this case here in SQL Server, stored in a transaction log file, and then eventually it's written into the MDF file. So it's just a temporary location. It's strictly there, it's primarily there, I'll say, for disaster recovery or data recovery. So we need to supply that. It built that for me when I used the right-click new database. It promise you if I go out there that content is stored there. I didn't get to specify where it went like I can here though. That was stuck in the default location, which is way deep in the C drive somewhere. I've created this to show you that you can specify where you want these files and what the name of these files when you're using this command. All right, let's see if this thing works. Now the cool thing is it's back in the query analyzer, query window here. It will only execute content that you highlighted. So you notice I've got some commands. I don't want these to run down here yet. So I'm going to highlight this content up here. And I'm going to go ahead now and I'm going to choose the execute up here. Or I can press F5. So either way will work. And it's going to go out, it's going to execute this command. Hopefully it will execute this command and create a new database called sales. All right? I've got it highlighted. I'm going to press F5 on my keyboard. It comes back and tells me command completed successfully. Well, if I go over to databases, was it called sales? I don't see it here. So let me right click and do a refresh. And here's my new database called sales. And if I want to look at the properties of this real quick, and it'll just be real quick, you'll see, just go with files for instance, here's my 10 and my 5, and here's my auto growth. And again, as Pete pointed out, I could have done all of this when I was doing the window, when I was going through the graphical user interface. I chose to show you just the quickest way for you to create a database, and that was the quickest way. And this is another way, if you get paid by the hour, to create a database is to write scripts. The cool thing about scripts too, I'm making fun about getting paid for it, but scripts are beautiful in the sense they're reusable. So this is another reason you may want to script some of this content here. All right, let's see if I can get this window back. I don't want this window so big here. Let's get this back down a little bit. Okay, so we have a database out there. Now, remember I talked about the use option. I need to add a table to that. So the idea that we talked about just previously was, hey, when you create a new table, you need to understand the type of content you're going to store in there. So this table I'm going to create is called Products 1. We're going to have a field in there called Product ID. We're using an integer value. All right, so I can store whole numbers in there. We're going to have product name, varchar 20. We're going to have unit price using the money data type. And we're going to have product description using varchar 50. Remember, if it's char, if that was a char 50 versus a varchar, even if it uses 10 characters, it's going to allocate space for 50. So it's a fixed length, where a varchar says only allocate whatever you need to store the content. So if this product description is only 10 characters, it's going to have storage for 10, not 50. So there's not a lot, so it won't be as much unused space. So what we're going to tell it to do is use the database we just created called sales and create this new table in there. So if I go over under tables over to the left right now, you're going to see I have system tables, file tables. Those were just tables loaded by default. Let's create our new table here. So I'm going to go in now. I'm going to highlight this because I can just highlight what I want. And I'm going to execute this. And command completed successfully. Let's do a double check over here. Let's go back to sales and do a refresh. And go back to our tables. And you'll see we have our new table here called dbo.products1. And if I expand on that, you'll see our columns. And you'll see the 4 columns that we specified here were also created there. So easy enough now. We've created a database. We've talked about what data types are. We've decided the type of content that we're going to store in that database. We're going to store in this products 1 table. And we've created a table now that will allow us to be able to enter content in there. We're going to talk about doing that a little bit later on though. Remember, right now we're talking about a data definition or DDL statements. We're talking about creating objects and modifying objects. So we created a database, we added a table to that database. Something else we can do, and so notice when I created a database, I used the create statement. If I created a table, I used the create statement. I create a view, I create a store procedure. Whatever I create, if it's an object inside a SQL server, I use the create statement. So it makes it simple for me. If I want to change the database, or I want to change a table, or a procedure, or a view, I use the alter statement. So I create a database called sales. I want to change that database name to sales forecast. By the way, that little green line that says right there what I'm doing, that's a comment. So anything that's got dash dash and it highlights it. Notice the color coding, by the way. The blue is saying these are actual statements. These are the fields. These are values that are supplied by Microsoft SQL Server. The dash says this. Ignore everything to the right of that. It's just a comment. So you can document. People always document late, but they always document what's going on here. So this is a reminder to me. Oh, I want to change a database. I can highlight it and try to execute it. Nothing's going to execute because it's a comment. But we're going to alter the database called sales. We're going to call it sales forecast. We'll hit execute up here. All right, the database name sales forecast has been set. Let's refresh. And we'll go over here. We'll see now our database now is sales forecast. So now we've changed the name of our database. Now if I want to delete the database, I've been asking Microsoft for years to change this from drop to toast. I like the command toast. I want to toast a database. I want to toast a table. It's still not toast. You can write a store procedure to do that though. You can write a store procedure that'll do the same thing as drop. And I've done that before. But we won't go there. It's bad. It's just going to stay with standard stuff here. So I want to drop the database, or I want to drop a table, or I want to drop a view. I use this statement right here. Toast the database. I'm going to highlight this. So remember over here we got sales forecast. We're going to execute. Ooh, cannot drop because it's currently in use. I must be connected to it somewhere. Modify name, toast database. Let's see here. I know another way we can do this. Go over to the right. And I can do a delete here. Now what's happened is I have a connection to it. So because that failed, I'm going to come over here. There's a connection to it. So my guess is if I do OK here, it's in progress. It's already taken too long. It's going to come back. It should give me pretty much the same type of deal. It can't do it. And they're going to take this long, or else I wouldn't have done this piece. But it's going to come back, but I'm almost positive it's because there's a connection established to it. And so what I'm going to do, okay, now it fails. Drop failed for database. Let me do this. Let me click this guy right here. Close connection. And do an OK. Hopefully that will do it.
You know why they don't call it toast, by the way?
Why?
It's because toasting the database would make it more delicious.
Oh, that's true. Usually it's
Right.
fatness. That's true.
Yeah.
That is true. All right, we got rid of our database. If you look over here, we got rid of it here. I couldn't do the drop database. There are parameters you can supply with that to drop existing connections, so we could have done it that way. But because I had established a connection to it, it wouldn't let me drop that database.
So it looks like a lot of the things that you can do with the user interface in SQL Server, you can also just write script to do.
And scripts, we're going to talk a little bit more about scripts. This is kind of an introduction to them because I want to bring these in so you didn't have to watch me fat finger everything. But scripts are really powerful, especially if there's redundant tasks that you're performing. And let's say I wanted to hand this off to Pete so he can go out and create the same database. I just send him this script. He can pop it into his SQL Server Management Studio. He runs it. He's got the same database with the tables and the alteration of it if he wants to. So it's easy enough to redo information or tasks that we're performing here. All right, let's jump back out into our slide deck. That's not where I wanted to be here. I need to drop this guy this way. No? Yes? Or am I going too far here? Oh, I'm coming way out. I know what I need to do. I'm coming out of my connection. I need to minimize that. Here we go. And let's go back into our PowerPoints, which somehow got closed. We're in what, Module 3?
Yep.
Yeah. All right, come on now, work with me. There we are. All right, so that's creating a database class demo DB. That's the one we created using the interface. And the one that we created, that we're going to create, we also created one using a script. And we deleted that one after we had added a table to it. DDL statements, that's kind of what we just did. So we actually did the create of the database. All right, and we did the create the table.
Remind me what DDL stands for again.
Data definition language. So this one, so we talked data manipulation language earlier, where we do the inserts, the updates, and deletes. Well, actually, no, we're going to talk about that next.
We're going to talk about that next.
Yeah, we're going to do that next. Sorry. So we did a DDL is a data definition. We're actually creating objects or altering objects or dropping objects. So it's the creates new objects, alters, modifies them, and drops or toasts any objects. And that's for database all the way down to views or stored procedures or anything like that. So the create statement, you saw it's used for database, table, default. Any of these can use the create statement. Here's that example that I supplied for you already. This is what I showed you for creating that database and the table. Here's the create new table. And this is the one I demoed for you. I think I did the demo first, and now I'm showing you the content. That's pretty funny. Went in the wrong order. I was supposed to create the database just inside the GUI.
We were both pretty excited about actually creating
and I wanted to do something.
the database.
I wanted to do something with scripts or with queries. So this is what we just saw. If you look at it here, it's not all color coded and all that cool stuff, but it worked. You saw that it worked. And alter the statement, as you saw, I took the sales and changed it to sales forecast. And drop statement, whether it's a database or a table, view, role, whatever it is. It's simple. For DDL, it's create, alter, and drop. If you understand those three, that's the bulk of what you're going to need to understand for DDLs, when you're data definition language statements, to be able to manage the objects inside a SQL Server. So this is where I was supposed to do the demo that we just did. So I did a dual demo.
But this is where, let's go back and actually talk about the graphical user interface and scripts. Show me the cool feature in SQL Server here about how I can get a script.
You want a script here?
Yeah.
We can do that easy enough. So what we could do...
This is one of my favorite parts of SQL Server because you can kind of cheat. Because the lesson here is that there's a graphical user interface way to do things, and there's a script way to do things, but you don't actually need to memorize how these scripts are created because SQL Server has this great feature that Brian's going to show us.
Yeah, so the cool thing, what you're talking about is, I created this database using the GUI. Now, I didn't populate anything in there or anything yet, but what I could do is after I create an object using the graphical user interface, I can come in here, if I can grab it here, and I can go into script database as, and I can have it generate that create statement for me. So that create statement I use to create the sales database, I can take this in any object, whether it be a view, a store procedure, a table, and I can have it generate this by using the create to. Now the other thing is the drop and create to. This is kind of cool because what it does, it adds at the top of the script, it adds to it. Let me just go ahead and kick this off to the clipboard. Hopefully that'll open up for me. Let me do a file so I know I can find it. And we'll call this class demo. See, even down here I use the Pascal case script. All right, it's going to save it as a .sql file. Lost my mouse again. Come back. So I'll open that up for you just a few moments. In fact, what I'll do is I'll do it in just 1 sec here. I'm going to go over here. I'm going to go into here, up into... Where did it save it?
It did not save it to the desktop. That's all I know. I didn't actually catch the path.
I always save it to the desktop because I'll lose it. So we're going to do it again.
I think you can just, when you go into the script database, can't you just do drop and create to a new query editor window and it'll just open it right up?
Yeah, okay, we'll just do it that way. I just wanted to show me we could save it out and I can ship it off.
And then you can save this file. This is just a document system where you can save the SQL file.
Yeah, and this is cool because look at it. I already said use master because it has to update this content master database. This is another way for comments. Do a / asterisk, and then you close it out with a asterisk / over here.
So let me just, because you just blew my mind again, I just want to make sure we talk through what just happened. Okay. You right-clicked on the database.
Correct.
You said drop and create into the new query window.
Where am I? Right there.
Generate scripts. Drop and create to, and then you said new query editor window. And SQL Server generated this whole file full of stuff that starts with the use, and then it says drop the database class DemoDB. So if you wanted to make changes to your database structure or say a table that you did, you could just use the generate script command.
Exactly.
You'd get a window like this. You could make the changes that you wanted, and then you could run the commands here to make the alter or modify or create changes that you wanted.
Yeah, maybe I don't like to, you know, like you said, it's going to drop the database. That's all right. So you can run this multiple times. I create it, yep, not quite the way I want it. Create it, not to, you know, and come back and change it. I don't like the location. I can change the location here and run it and create it again.
Got it.
Multiple times. And the cool thing is it's scripted. I can create it. I like it. It looks good. Pete likes it. I send it off to him. He can execute it inside of his SQL Server.
So I just kind of blew up your whole logic about getting paid by the hour and writing scripts because you just showed me how quick it is to generate a whole bunch of scripts that I can just go modify.
Yeah, so your manager's going to like that.
Right.
That's here I'm saying, you know, my manager's going to be like, what, really?
I'm all about getting it done faster.
No, I am too, definitely. Yeah. And here's some other alter database statements. So it generates a bunch of items for you. These are all the parameters we're not going to worry about. But the idea is we can generate scripts. Again, that could have been a table. It could be a view. Anything that you have for objects, right-click, generate script for. And there's often it'll have the drop. I always put the drop there. That way in the event it already exists, it won't. Because without that drop, if I tried to run this, it's going to blow up, say the object already exists. So to avoid that, you can just actually go out and drop that item.
The other thing I wanted to point out is I think this is a really great way to learn how SQL Server is doing things because sometimes you can page through the graphical user interface to discover all the options, but you can also, if you like to read the script code, a lot of people are into the sort of programming aspect of databases. You can use this generate script command and actually get a big file of T-SQL.
Yeah.
And then you'll discover all kinds of features that SQL Server has as you parse through that script and see what's in there.
Yeah, good example of that too is if you want to write your first store procedure. Man, it's like I know Brian said you could pass parameters. There's a ton of store procedures coming out of the box. Right-click, generate a script. You get that for a basis now, and you can use that for writing your own store procedures now. All right, so is that all I wanted to do in here?
Yep.
Okay, good.
Yep, I think it's about time to wrap up the module.
I think it is, definitely. So let's see where we are. I'm sure
We've covered a tremendous amount of ground in this
know, it's
module.
fun.
We went from fundamentals to suddenly we have our own database with a table. Granted, we didn't really create all of the details of the table just yet, but we're on our way to doing that.
Yeah. Yeah, so we got to talk about data types, the different ones there, how to create the database, both the SQL, SSMS, create, alter, and drop objects, Pascal case or camel case. Choose one of the two. All right, make sure that you do that. Don't leave it. Don't mix them up. You already know my preference. I won't go in there again.
You know what we should do before we wrap is we should talk through, let's just go back to the original example that we used. Let's go to the, you want to use the grocery store one or the CD library
I like
one?
the CD library one.
So the album one, we started with the spreadsheet, my giant spreadsheet of all of the records.
Right.
And then we did some normalization on that. We decided that we were going to start with 3 tables, an albums table, an artist table, and a genre table.
Right.
And what we learned in this module is that to really actually create those tables, we need data types for those things.
Right.
Right? And then let's just talk through the album one. If it has an album ID as a primary key, then what would you think a data type would be for that?
That would probably be an integer.
An integer, because we know that integer goes up to
32,767.
32,000.
32,000-ish.
So for my database that has a few, let's say 100 albums in it, that's probably a limit that's appropriate. So I'd make a choice for the data type for my primary key, because I don't think I'll ever go over 32,000 albums in that list.
Yeah, might even actually. I think that's a tiny int. This is there's tiny int, there's small int, and so but integers like huge.
And the point is,
number.
You'll think about the data types that you have, and you'll think about the data that you're going to put into that table, and you'll make an appropriate data type decision based on the data that's going to be in that table. So album name, we'd need to decide what we think the longest possible name of an album is, and then make a data type decision based on the data. So this is more of that data modeling stuff. We're not going to give you lots of guidance about how to do that, but these are the kinds of questions that you'll have to think about when you're actually creating. You'll have to first understand your data, and then understand that there are data types to make choices about. Then when you create the table, you'll be able to make a smart choice about what data type to use for those things. So I just wanted to kind of reiterate that's how we hooked it together from the first couple of modules to now what we've just learned about. We create the database, we know it's going to have a bunch of tables. The tables are going to have these data types, these fields with different data types that are appropriate for the data that's in them.
Right, exactly. And then the next module, we're going to look at some of the awesome commands that we had to be able to go and actually grab this data and slice and dice the information. So, all right, so this wraps up on creating the database and the objects. We're going to look forward to taking a peek at the how we manage that data down.
Let's do it.
Okay.
Thanks.